Hey everyone, welcome back to the Spring AI Complete course. I am Kumar Pallav and today we are doing lecture 5, that is tool calling. In this lecture, we'll see how your chatbot stops being the chatbot and starts being an agent. Let me show you what I mean. Here is the core problem with every AI you have built so far. Your model knows everything that was in training data up to the cutoff date, but it has zero awareness of right now. It doesn't know what time it is. It doesn't know what's on your calendar. It can't check the weather, place an order for you, or set an alarm. All it can do is that it can talk, and for production application, talking isn't enough. Let me show you what is possible. Imagine you ask your Spring AI application, check my calendar for tomorrow and tell me if I need an umbrella in New York. Without tool calling, model makes something up. It hallucinates a date, guesses the weather, and it's completely useless. With tool calling, model call get calendar event and get current weather for NYC. Get the real data back, synthesizes a real answer. Same model, same prompt, completely different capabilities. That is what tool calling unlocks. So how does it work under the hood? It's a 3-step loop. Let me walk you through it. Step 1. You send user's message to the model along with the definition of your tool, the name, the description, and the parameter and the schema. The model doesn't get the tool code, it just gets the contract. Step 2. The model decides that it needs a tool. It sends back a tool call response, not just an answer, just a structured request. Please call track package where the tracking number is TRK8221, for example, right? So, in case that you want to track a package, basically that is what it will do. Step 3. Your application executes the real Java method, your code, your environment, your security context. Then you send the result back to the model. The model never executes anything directly. It is international. The application is always in control. Now let's write some code. We will start with the simplest pattern, that is information retrieval. Here, the shipment tool class is a plain Java class. No interfaces to implement, no boilerplate. You just add @tool to any method you want to expose. The description field is absolutely critical. This is what the model reads and decide when to call your tool. Be specific. Write it like a documentation for the model and not for the humans. The return value comes back as a string representation. Spring AI handles the serialization via tool call result converter. Then on ChatClient, you just pass .tools, the shipment tools. That's it. Spring AI generates the JSON schema automatically from the method signature. Let's create a new class. We'll call it shipment tools. Now let's add @tool. Now let's go back to the controller and just create a new endpoint to track it. Here we have added a new URL AI shipment track. So whatever tracking number comes, the LLM should have an extra context because it has got the tools. Using these tools, it will try to understand which particular method to call, and then it will return the response not only from its traditional trained data, but also it will use the new tools available just to understand how to actually resolve the user query. So as you can see that you got a response Not exactly what we are returning, but the LLM has acted onto it and trying to actually give you a much meaningful response back. So now this shows how you can actually call the tool. So while this was the use case 1, let's look at the another use case. The second pattern is taking action, not just reading the data, but changing the world. Here, an add to the cart tool is created. Do note that this can even return a void, and that's fine. A tool call with void will work. Notice at the rate tool param. This is where you give the description and any format hint. The model will structure its tool call to match. This is where security model matters. You are giving the model the ability to do things. Add item to the cart, place order, write to your databases. Your application code is the gate. The model can request, but you decide if it executes. So you can see here that we have added a new class called cart confirmation, and we are telling that if I pass a product ID and the quantity, basically you can write the service method and you can actually call to your databases and do whatever you want. And then we are returning back a cart confirmation just telling that product has been actually added to the cart successfully. Now to check that if this does work, I'll just create one more endpoint here. Let's see if we do get the response back and we do have a product along with its quantity getting added. And it has not only responded back, but responded back with a JSON output by converting it in a format of a cart confirmation. While this is a part of the next lecture where we will discuss this feature in detail, so we can have a preview here. Now let's look at the full @tool anatomy. Name. Now let's look at the full @tool anatomy. Name here is an optional field. Defaults to the method name. You can override it for your method and it isn't descriptive enough for the model. The description is a mandatory in practice. If you skip it, model has no idea when to call your tool. Write it in plain English, model reads this. Return direct is a Boolean parameter. Default is false. When it is true, the tool results bypasses the model and goes straight to the user. Use this for lookups when you want the raw data and not synthesized prose. Result converter lets you customize how do you want to return the serialized value. By default, we use Jackson, and you saw right now. You can override it if you have your own complex type. In case if you are a lot more interested to understand this, you can read the official documentation also. So these are those 4 which we discussed right now. Now let's just look at the wiring tools to the chat client. So one of them is pre-call. So .tools, new shipment tools, as we are passing it via instance only, so these tools are available for one call only. Then comes defaulted via builder. So default tools, new shipment tool, every call through this particular chat client's instance will have the access to these tools automatically. Great for global utilities like shipment tracking in a shopping assistant. The third way could be Spring Bean by name @bean with description, then reference it via .tool names. This is a functional style. You hand Spring AI the function with the request and response, and it wraps it. Useful when you already have a service bean. My recommendation is to use @tool for most of the things. Use the functional style when you already have services wired up into your context. Okay, let's talk about Spring security. This deserves its own slide because it is one of the most misunderstood part of the tool calling. A model never executes your code. Your request's execution does. Your application decides whether to honor that particular request. This means your Spring security context is intact. Your database transactions are yours. Your validation logic runs. You can add an approval step just by adding internal tool execution enabled false and prompts the user before any action runs. Your model can say delete a user, but it never runs your code. So if your code has a guard, nothing gonna happen. This is why description you write in at the root tool matters. So whatever description you are writing over at the rate tool annotation is because you are telling the model what tool does, which shapes when it will be called. So write it very carefully. Now let us look at another powerful feature. This one is called tool context. This lets you pass user-specific or request scope data into a tool without putting it in the prompt. So your tool method adds the tool context as a parameter and Spring AI injects it and the model never sees it. It never shows up in the JSON schema. Then in ChatClient, into the tool context, you can use it as a map of account ID or whatever it is required for you. Inside the method, you put it out using tool context.getContext.get. Since you were already have added it as a map, so this will be retrieved. It's a clean, secure, and no leakage into the prompt. Use this for authentication tools, account IDs, user sessions data, and anything that should travel with request but never should be visible to a model. Now let's look at into the code. So in this particular get mapping that we have created, we are providing the user ID as part of the context. So user ID which is coming from the incoming request, we are adding it into the context and we are passing it. LLM will never have the understanding what user ID has been passed. So this user ID stays inside your code. And inside the shipment tool, we have created another tool which is get order history. Here we are injecting tool context. While this tool context is injected, model only understands that okay, to get order history, I have to use this particular tool. And the required data get injected via the tool context. And this works exactly as your other Spring application should have worked. So just to retrieve it, we have created another class called order and we have added few parameters out there. So this is the order class that we have created. Let's run this particular application. We'll go back at our controller. We'll just get this AI order and then we'll pass it the use with a dummy user ID. Let's see if this actually works. We are using AI/orders and passing a dummy user ID. Let's hit the send button. And here is the details that we have got. We will go back to the ID and verify the logs as well. Let's look at the logs. In the logs, you can easily see what is happening. You can see the response for the user ID which is coming from the response, but you can also see a log telling retrieving history for this particular user ID, and this one is coming from the shipment tools. That's why for all the authentication tokens, account IDs, user specific session data, everything that should travel with the request but should not be visible with the model should go via tool context. These are the common mistakes, so let's talk about them. Giving a bad description. If your tool description says get data, the model will know which data to call. Write description as you are documenting your API. Be very specific about what data, what format, what are the side effects. Too many tool calls at once. If you expose 30 tools with model in one call, it might get confused and may not call any of it or may call the wrong ones. So start with 5 focus tools. unsupported types. Method tool don't support optional completable future, flux, or mono. Keep your tool signature simple with string, primitive, records, or pojo. Ignoring the execution loop. If internal tool execution enabled is false, you need to handle the loop yourself. Forgetting this means the model sends back a tool call and your app just returns it raw. So let's look at the key takeaways from this particular lecture. Tool calling is a three-step loop. Model requests, app executes, and results are returned. Model never runs the code directly. Tool is the simplest approach. One annotation on any Java method. Spring AI handles schema generations automatically. The description field is the most important field. The model uses it to decide when to call which particular tool. There are two particular patterns. You can do information retrieval, you can read the data and return it, or taking actions like changing the state or the side effects. Both are valid. Know which one you have to use and for what you are writing. Tool context is how you pass secure request scope data into the tool without polluting the prompt. Your app is always in control. Tool calling gives the model the reach, but your code still decides what actually runs. Before tool calling, your AI knows what it was trained for. But after the tool calling, it can interact with the world. So now your chatbot turns into an agent. In lecture 6, we go onto the other side of the conversation. Instead of giving the model tool to act, we are going to make the model return a structured Java object. Type safe Pojo map AI outputs. That's the structured output. I'll see you there. In case if you have learned anything from this particular lecture, do subscribe the channel. It helps me to create better videos and be consistent. Thank you.